Now see this problem here. An optical fiber is kept along the z-axis. The refractive indices along x and y direction has been given, and the wavelength, free space wavelength, has been given. They has given this as a lambda. Free space wavelength, if I say lambda naught, so how much it is? 1.5 micrometers. And there is given a refractive index along x direction given as a 1.5. Along this y direction is given as a 1.5001. So that means refractive indices along x and y directions are not same. So that means this type of medium is a anisotropic medium and a non-homogeneous medium. So refractive index of any medium, which is given as what now here? Square root of epsilon r now. So epsilon r, refractive index is different, means epsilon r is different now. So that means medium parameters are different. So this type of medium is called as a not homogeneous, inhomogeneous medium. Inhomogeneous medium. And as well as they has given is a dispersion medium also. Dispersions. Now what they are saying is initially the incident wave is what? Circularly polarized. Initially the wave is a circularly polarized. Circular polarization means it may be a left or may be a right circular. So let us consider it may be a left circular, no problem. Even if we consider right circular also, the analysis is same. So for consider this initially the wave, the electric field expression, which is in the form of, this is E naught into ax plus jay into e power minus j beta z. Now what's the polarization of this wave? Circular. Amplitudes are same now here. Here this amplitudes E naught only, phase difference is j, means what? 90. So what it is, a circular left or right? This is the left circular polarization. Now so this is the circularly polarized wave. What is the condition for circularly polarized wave? The phi we used to say now. What the phi is now? The phase difference between x component and the y component is how much it is, a plus or minus what? 2n plus 1 into pi by 2. Then we can call that as a, and of course the amplitudes also equal, magnitude of x and ey must be same. Then we can say if this condition satisfies, then we can call that as a circularly polarized wave now here. Then this is a circularly polarized wave. Now consider for this circularly polarized wave, this wave, let us say that I added the some phase angle to this wave. Let us consider here, this is this what I did now here. This is E naught into only one component, not two components. Let us say one component added some phase angle. So let us consider this is ax plus j into, let us a y component add the one some phase angle. Let us say phase angle add pi by 2. This is ay into what I did is amplitude same. Let us say amplitude I didn't disturb, I disturbed only the phase angle. Consider, see what happens now. The amplitude is 1, phase angle I did the plus 1 more pi by 2, I did like this. Assume that if I did like this, then see what happens now here. Now this is E is equal to what I can say, Can I expand this in normal form, electric field? So I can say E naught into what I can say, cos of omega t minus beta z into ax plus, and then what happens now here, this is j, this is one more pi by 2, so this I can write it as E naught into cos of what, omega t minus beta z plus pi by 2 plus another pi by 2 will come. We assume that we added like that. Then see what happens now. We have E is equal to E naught into cos of omega t minus beta z into ax plus. Now this is what now here, cos of pi plus some theta form I can say. What I will get is cos, this will be negative now here, minus E naught into what now here, cos only na, so cos omega t minus beta z into what now, ay, isn't it? Now tell me the polarization of this wave now. Polarization of this wave now, how much it is a, see this thing, amplitudes are same and phase difference we can say it is a what now here, phase difference is a, if the phi, if the phase difference between the x and y component which is equal to plus or minus n pi, amplitudes may be same, may not be same, then it is called as a what, linear polarization. Linear polarization, isn't it? So from this what I can say now here, what I can say here, if I add some pi by 2 phase angle to a circularly polarized wave, it will be converted to a linear polarization. Of course that is for only one component, not two components, one components. Now see the problem what they has been given in this case now here. Initially the wave is a circularly polarized wave, and after traveling some distance it will becomes what now, linearly polarized wave. For that to be converted to linear polarization, what the condition must be, it is a, and either we should add the plus pi by 2 phase angle or we need to subtract. If I can able to do that one, that is for only one component, then it will be circular will be converted to a linear polarization, isn't it? Now see this thing here, they ask into how much the distance the wave has to travel to get it is a circularly polarized wave to a linearly polarized wave now. For this what I can say now, initially, now hope you understand this concept. Now coming to this problem here, the electric field expression which I can write it as, in this case E naught into what I can say, cos of omega t minus beta x into z ax cap plus E naught cos of what I can say, omega t minus what I can say, beta y z into ay cap now. Initially what they are saying is the wave is what, polarization is a circularly polarized wave, the phase difference, and earlier we used to do the problems. Now generally we should take the z is equal to 0, then this value will be beta, this term will become 0. But previously we used to consider the mediums are homogeneous mediums. In homogeneous medium, beta everywhere is constant. Here either whatever the phase angle increases here, corresponding this phase also will changes. We assume that be homogeneous mediums, but in this case the mediums are not homogeneous medium now. So in that case what happens now here, the permittivities will changes from medium to medium. Now here So here now what the phase difference must be in this case now to get a initially it is a circular, now we should need the linear. Now for that what the condition must be, I can say here the phase difference must be, that is beta x z minus beta y z must be equal to what I can say, pi by 2 plus or minus pi by 2. Yes, so from this what I can say here, z into what it is, a beta x minus beta y, that must be equal to pi by 2 now here. And what is the beta x? Beta, as we know, that is beta is equal to 2 pi by lambda. What the lambda is, a wavelength. So here they given this wavelength, but where this wavelength is given, it is a free space wavelength. That is a wavelength in the free space they given. They're not given a wavelength in the medium now. So what we can write now, in general wavelength lambda, what we can say, it is a velocity by frequency. Frequency of the wave is same, that is lambda, I can say it is a velocity is c by what I can say now here. Yes, now c by, this is f into square root of epsilon r, I can write. And so this is this lambda which is given as, I can write it as what now, it is a lambda naught by square root of epsilon r, I can say a lambda naught by square root of epsilon r. So here, so square root of epsilon r, as we have seen now, square root of epsilon r which is given as what now, refractive index only now. So here if I say this is, if I want the beta x, then I should say this is a lambda x, I can say. Then I can write this as, so the lambda x, then I can say epsilon r. So from this I can write it as lambda x is equal to lambda naught by, I can say this as a nx, I can write. For nx is the refractive index along x direction. They given a refractive indexes are different for two directions, x direction, y direction different, they has been given. That is because of this one non-homogeneous mediums and the dispersed medium, these things will happens, right? Now so that is what I can say, this is 2 pi by what I can write now here, lambda naught into nx. And what a beta y is, that is 2 pi by lambda y, that is 2 pi by, similarly I can write lambda naught into ny, I can write ny is a refractive index in the y directions. So finally we got this equation now here. So this is the distance has to be traveled. So from this what I can say now here, z into what now here, beta x minus beta y. So this is 2 pi nx by lambda naught minus 2 pi ny by lambda naught, which is equal to how much it is, pi by 2, right? Pi ne pi ko mara. So finally what will get now here, z is equal to, yes, get the z value here, this is lambda naught by 2 into what, 1 by 2nx minus 2ny, check it. So this is z is equal to what I can say here, that is lambda naught by 4 into 1 by nx minus ny. So of course here we have taken this as a phase difference is a, it may be pi by 2, maybe plus or minus pi by 2 will happens or not. So you no need to worry about this thing as a, it is a minus or plus. Here the nx, what the nx value given as a 1.5 and the ny will be given as 1.5001 given now. The ny value differs, so I can write it as z as a lambda naught by 4 into, I can make it as a ny minus nx. I can write, it doesn't differ, isn't it? So we need only the positive value of distance only, right? So, and do simplify this thing and get the value of z. What the z is, this is the minimum distance the wave has to travel to convert, to make the circularly polarized wave to a linearly polarized wave. And do simplify, get this answer. Thank you.